Hello, welcome to this session on using the unit circle and the cast diagram. Well, here's the unit circle. Here's an interactive version of it from mathsisfun.com. Just if you Google this, if you Google Maths is Fun interactive unit circle, you'll find this no problem. Just up here for reference, I put some sine, cos, tan values. You've got your cosec, your sec, and your cot values. Remember, cosec is 1 over sine, so that's the reciprocal of sine. These are reciprocals, sine and cosec. Cos and sec are reciprocals, and tan and cot are reciprocals. So cot would be cos over sine. Tan is sine over cos. Here's the key values. There's your degrees, there's your rads, and here we go. Here we've got the unit circle. It's a unit circle because all the way around the radius is 1. And here you've got the graph from 0 to 360 of sine, cos, and tan. So let's have a look at how we use this. Okay, so we've got here a radius. The radius is size 1, and I can move that around a circle. As I move it, you can see the graph is changing. The point on the graph is changing. I can put coordinates on here. I can put the quadrants on, if you notice. So here I'm in the first quadrant, where the x and y values are positive, and I move around anti-clockwise, second, third, and fourth. I'll just get rid of those quadrants there because they're a bit clunky, but you get the idea. You can see the quadrants also on the graph. You just need to know where those are, really. Get rid of those angles. You can see the angles. On there, so we can go between degrees and radians. There you go. I'm just going to use radians for now. I could get rid of the circle if I wanted, but it's a bit messy without the circle. And if you replace the circle with a compass, I don't like it. I prefer the unit circle. So let's have a look at how we might use it. Okay, here I've set up the angle pi over 6. So if I've got a unit circle of pi over 6, that means the radius there, that the radius is 1. It creates a nice right angle triangle within the circle. The hypotenuse is 1. Opposite is 0.5 and adjacent is 0.866. Well, what does that refer to? Look here. Pi over 6, sine is a half, 0.5. There you go, opposite, 0.5. Opposite over hypotenuse, 0.5 over 1. Cos of pi over 6 is root 3 over 2. Well, that's 0.866 to 3 significant figures. And tan, well, tan would be the gradient of this line. So tan would be 0.5 over 0.866. Or more accurately, a half over root 3 over 2. And that gives you root 3 over 3. So it just you can read off here these values. There's sine of that here, cos of that, tan of it. This bit of software, this applet, shall we say, is giving you a decimal version of pi over 6 there. But you can see clearly that's pi over 6 here. We have this here for reference in this instance. It's a nice demonstration. And then it's on the graph as well. So here we are at pi over 6. Now, what the unit circle shows us nicely is the x-coordinate here. So this has an x-coordinate of root 3 over 2. Well, root 3 over 2 is the cos value of this angle. A half is the sine value, so the y coordinate is the sine value. So this gives an angle. We have an angle, and the x coordinate will be the cos value. The sine value will be the y value, so sine of the angle would be a half, sine of this angle would be a half, cos of this value would be root 3 over 2, and the gradient of this line. Now you might want to think, well, where else has the same cos value? Well, let's have a look. Where else on the circle has the same x coordinate? I have to go down here. Root 3 over 2. 11 pi over 6. Well, that makes sense. Think about the pattern of our graph. 2 pi minus pi over 6 is 11 pi over 6. If you like, 30 degrees and 330 degrees, when you think back to degrees. Okay, well, I've just demonstrated that on here. I've just moved it. So here, well, I've gone all the way around to 11 pi over 6. It's got this point here on the circle that the line meets. When I make that angle all the way around here, 11 pi over 6, or 330 degrees if you're working in degrees, gives me still root 3 over 2. The sign's not the same though. You've got sine as a half, and that's negative a half. So with this unit circle, you're able to spot patterns like this. Very useful. So if it's got the same x coordinate, the cos value of these angles, pi over 6 and 11 pi over 6, are indeed the same. Well, I've moved it again. This time I wanted to get the same sine value. I wanted to get the same sine value. Well, the sine value there is the height. It's how far it is above the x-axis, or the y coordinate, which was a half there. So here, look, that's a half, and I've gone start there, gone all the way around there. 5 pi over 6, 150 degrees, if you like that. And I get, see, I'm at the same height, so sine of 5 pi over 6 is 0.5, the same as sine of pi over 6. We can also see this in the shape of the graph. This is the point of the unit circle. Now remember I said we think about tan as sine over cos. Well, it's the gradient then, isn't it? It's the gradient of the hypotenuse of this little triangle we're making. So if I go all the way around here, to get the same gradient as that, I need to join the line on. So I can just go round and add 180 until I get it on there. I do find it a little bit tricky to get it there. It is, it's there. So that had the same. So tan of pi over 6 is the same as tan of 7 pi over 6. I add pi, or if you're in degrees, you add 180, and that's a demonstration of that working. So this is your unit circle. It, alongside the graph, tells you equivalent values of sine, cos, and tan. It tells you where, can show you the multiple solutions. I say, well, what sine value gives me a half? Well, pi over 6 does, and over there, 5 pi over 6. Very useful. Okay, so here we have a cast diagram. It tells what the cast diagram does. It tells you what's positive out of sine, cos, and tan. Here, well, in the first quadrant, everything's positive. Sine is positive, cos is positive, tan's positive. Here's the first quadrant, and as you can see, they're all positive. They're all positive. Your cos, your sine, and your tan. Now if we move into the second quadrant, which is between pi over 2 and pi, or 90 degrees and 180 degrees, only your sign is positive. Everything else is negative there. Third quadrant, that's between pi and 2 pi over, that should be 3 pi over 2, there's an error there. So between 180 and 270, just look at the error there. So only tan is positive. At that time, you've got cos is there, sine is there, they're both negative. In the fourth quadrant, which is the fourth quarter between 0 and 2 pi, or between 0 and 360 here, only cos is positive. And that's why it's called cast. Cos here, all, sine, tan, cast. And that really just reminds you about the sign of the cos value. It's taken from the unit circle. You understand the cast diagram of the unit circle, alongside the graph, it can help you. Okay, let's start to think about why this might be useful. So suppose you ask me to find sec 300. Well, to find sec 300, I need to know cos 300. Because sec is 1 over cos. So I think, well, 300 is not a principal value. I'll do a sketch of a unit circle. There's 300 degrees. And I think, well, there's that cos value there. As you can see, I'm marking it. I need to find on the unit circle where the same x coordinate is. So it's up there. Well, how many degrees is that? Well, I can see, okay, well, I've gone 30 degrees round from there. There's 60 degrees round there. So that's got to be 60 degrees. That's got to be 60 degrees by the symmetry of the circle. I could do this with a graph. So I know, okay, cos of 300 equals cos of 60. These are the same because they've got the same x coordinate on the unit circle. Now, it's one of your principal values. It's one of your key values. Cos of 60 is a half. Well, what is sec of... So cos of 60 is a half. So cos of 300 is a half. Sec of 300 must be 1 over a half then. It's the reciprocal, which is 2. So sec of 300 degrees equals 2. So I'm asked something like sec of 300. I know it's 1 over cos 300. And I can refer back to my unit circle. That's where it may be useful. Okay, let's have a look at a bit of a trickier one. Suppose you need to find cosec of negative 3 pi over 4. Well, what are we talking about here? We're talking about doing negative 3/4 of pi. So we're looking at what's going on here. There's the circle, kind of. There's negative 3 pi over 4 rads, and I'm there. Well, what we're doing there. So that's where we are on the circle anyway. So I start to think, well, cosec is 1 over sine. So I think about, okay, sine of negative 3 pi over 4. What does that equal. Well, look at the height it's at. So I go across there. Well, what's at the same height? Well, I could say that's negative pi over 4 rads. Or if I wanted to go all the way round that way, so if I'm going clockwise in a positive direction, it's going to be 7 pi over 4. But if I go anti-clockwise, I go negative angle, it's negative pi over 4. Well, let's have a little bit of a think here so we can see the pattern. We need the y coordinate here. It's the same as the y coordinate here. Now, a useful way to look at it would be to think, well, what is the y coordinate there when it's pi over 4? Well, what is sine of pi over 4? Sine of pi over 4 is 1 over root 2. So here, sine of negative pi over 4 would be negative 1 over root 2. So I can say, okay, sine of negative root 3 over 4, that's going to be the same as sine of negative pi over 4. Well, that happens to be the same as negative sine pi over 4, which is going to be negative 1 over root 2. And I've just done that. I've built that up from understanding the circle. So my answer to this question here is the reciprocal, 1 over negative 1 over root 2, which is negative root 2. So Cossack of negative 3 pi over 4 is negative root 2. Let's recap. How did I do that? Well, I looked on here, on my scruffy circle. I went, well, there's negative 3 pi over 4. It's got the same y coordinate as negative pi over 4. You can go in the negative direction if you go clockwise. Well, that would be the same but negative y coordinate of pi over 4. If that's 1 over root 2, that's negative 1 over root 2. So that relationship there is quite easy to see. You can also see it on the graph. Anyway, that's just a little introduction to using the unit circle. Hopefully, despite the poor drawing there, that's clear.